Hello, I'm Adam, and this is Philips Hue Ledstrip Controller, and this thing is generally can be bought in a kit of controller and 2 meters LED strip. And the problem with that is there only comes in 20 watts maximally at 24 volts. So it doesn't matter if you connect 2 meters, 3 meters or 10 meters, it will always have the same power consumption. So generally it doesn't matter if you extend your strip or not, if you want more light. I found a solution because I wanted a Hue LED strip in my hallway. And I need about 13 meters of the Hue LED strip, but I won't use only one controller. I'm about to split it into 2 controllers just to make the current lower on the components. And so in this video I will show you how to modify your Philips Hue LED controller to to let it stand triple power that it has from the factory. I love doing something like this. Let's first open it. Okay, it has 4 latches. And okay, we are in. We need to take out the board somehow. Okay, and we are in. And this is how the Philips Hue LED controller looks. It's the version 4. Generally nothing special, just the MCU, transistors to turn on and off selected color, and the capacitor, and what's important, those resistors. Those resistors are sense resistors. That means the microcontroller is sensing the voltage drop on those resistors, and it's calculating the current, the power consumption of the LEDs, and it's limiting of course the brightness to maximize the available current. In this example, for 2 meters, the maximum value is 800 milliamps. So the rule is, we consider, let me check, yes, we consider there are 4 resistors connected in parallel, and each of these resistors has a resistance of 0.24 ohms. 4 of them are making this resistance, and we want to make it lower, so the voltage drop will be lower, so the ECU will think there passes, for example, half amps, but in real there will pass, for example, 1 amp. And that's the first thing to do. Second thing to modify is the capacitor, because I read somewhere that if we are increasing current, there might be some noise coming from this, and the recommendation was to replace this capacitor for a bigger one, from 1000 to 2000 microfarads. I chose the 1500 microfarads, 35 volts, it's very enough. And two words about those transistors. Those are capable of switching current, which I'm about to put there, let's name it. and just be aware of limitation. Why I split it into two pieces, two controllers. I read somewhere that those transistors can successfully switch current about 7 amps or something. So generally that won't be a problem with the transistors. Yeah, we can keep them. But the problem is with those pins and the whole LED strip and the connectors. I hope those pins are rated for 3 amps. So because in standard gold pins are rated for 3 amps, so I assume those pins are rated for 3 amps. I checked under temperature camera how does it look, and generally we are getting let's say visible hotter area than other, but up to let's say 40 degrees I think it's still safe for this transistor, so I won't see a problem. I don't see a problem. Connectors are not heating up, so I think we are safe. And anyway, if we get too far with our modification, anyway, what can happen? Something can melt and let's say disconnect by itself, and generally that's it. So, but anyway, if you are doing this, do it on your own and leave it alone for testing for some days, turn it on for a couple of hours or something, just to make sure those are not overheating and yeah, it's safe. Yeah. Okay, so the first modification will be with those resistors. I planned there should be a formula for calculating that, but unfortunately, the calculations versus reality was very mismatched. So I won't give you a formula because it doesn't make sense. I will tell you a way how to test it properly and how the LED strip behaves, because it's interesting. Okay, let's move to the topic with the resistors. There are 4 resistors which are creating a resistance of 0.06 ohm, and I'm about to add their 3 1-watt resistors which has resistance 50 milliohms, so the 0.05 ohm, and it will result in overall general resistance 0.013, so a few times less, and it with my test it should give us about current lock on about 2.8 amps. So that's the, let's say, first input, yeah, because I discovered those values. Okay, that's how it looks. I'm not proud of it, and I would suggest different resistors, different size. There I've got 2010 resistors, and they are way too big. The correct size is 1206, I think. I'm not sure how about watts, but more is better. Generally it will work. It will give me 0.013 ohms, so yeah, it's fine. The next step, we are going to remove the capacitor. So I used the 1500 microfarads capacitor, and but before that, just I don't know, just because of yes, I want to make a little heatsink for those transistors. So I found somewhere something like this, and the plan is to make it maybe like this. It will be fine. I will use a thermal tape which I use on the CWWK to mount the heatsink. But before that I will disconnect the capacitor. Okay, and now we are going to somehow reinforce the connector just to be safe for that. But I just, even if there will be a fire, so it will somehow cover it, yeah? That's the rule, let's say. Okay, something like this is fine. It's not touching anything. Okay, and it seems it's ready now. I have to cut the remainings of the capacitor legs, and generally, yeah, I'm not proud of this. I will show you the first controller, which looked way better. So, a few words about how does it work. When you connect the LED strip and you connect the power for the first time, the LED will go up and it will increase the current consumption, so it will increase the brightness of the strip. You won't see the brightness increasing, but you will see increasing current, then to the limit which allows which is allowed by new resistors. So when I had 0.013 ohm, the limit was set at 2.8 amps. And the LED strip, let's say, rebooted and went for max current. So it's some kind of calibration. And by watching the current consumption, you will see how much current you gave it. And this is, let's say, scenario for checking the real value, how you which resistors have you chosen. And of course the tin is making some resistance, etc. So yeah, we'll see. Okay, and after that I will just use electrical tape to cover it and it's fine. Thanks for watching, please leave a comment and hit the subscribe button, bye!